NoSQL databases rely on sharding. Sharding is a data distribution strategy. This strategy distributed files in segmented chunks of, for instance, 64 megabytes for HDFS and 256 megabytes for MongoDB, for instance. Chunks are distributed over the cluster in order to distribute the computation and the data. Data are placed according to a sharding strategy. The first one is HDFS. HDFS stands for Hadoop Distributed File System. It is a resource allocation-based strategy which knows where the servers are placed inside the racks, how many servers there are per switches, how many servers there are in this data center. And the aim of this strategy is to face the fault tolerance problem and also to massively distribute the computation. So if you want to choose this kind of strategy is for fault tolerance and massive computation. The second strategy is clustered index. It's based on the tree-based structure. This structure sorts every information according, for instance, by identifier or whatever attribute you want, but only one. So you sort the information in this tree, and you can decide this solution to deal with physical data clustering in order to handle the different types of queries you want on a specific information, and also to deal with dynamicity inside the chunks, just because the amount of data that are provided inside the chunks can evolve. So it distributes the information over the chunks and over the data center. The third strategy is DHT, which stands for Distributed Hash Table. It is a hash-based structure, and this structure is very wide, and the aim of this structure is to deal with elasticity, just because you can add many servers and remove them according to different needs. And the main issue that is dealt with DHT is self-management. Just because in DHT you have no point of failure. It's different from HDFS or clustered index, just because HDFS, you have the name node. The name node is a central node that knows everything. So it's a point of failure. And for cluster index, you have the tree-based structure. And this tree is known at one point. Even if it is replicated 3 times, it is a point of failure. So for DHT, it's very interesting just to know how to distribute the computation, but also to have no point of failure.